So we're going to finish up section 7.2. That's why I called it B, because we didn't quite finish it yesterday. All right, let's see. I mentioned this briefly at the end, but I'm going to... I'm not going to go through the proof of it, but I'll show it to you. I think. Yeah. Got it. Right there. And then right there. So this is going to be a rhombus. So I'm going to try... That kind of looks like a rhombus, doesn't it? All four sides are equal. Pretty close. We'll say it is. All right. So what I'm going to do... let's put this in a different color. What I'm going to do is draw the diagonals. What do we know about the diagonals of a rhombus? Anybody remember from when Well, they bisect each other because it's a parallelogram, but specifically because it's a rhombus. What happens? What happens to a rhombus, to the diagonals of a rhombus, that doesn't happen to just any general parallelogram? They make a right angle. They're perpendicular. Exactly right. Okay. So this angle right here is going to be a right angle. If this is a what?
Rhombus.
A rhombus. Okay. So let's write that down. All right. So if it's a rhombus, the diagonals are perpendicular, and they do bisect each other as well. And the reason they bisect each other is because it's a parallelogram, and we know that diagonals bisect each other when it's a parallelogram. Now, we kind of did this with the kite. The same kind of thing happens. We could split this up into two triangles. I could talk about the diagonals bisecting each other, find the areas of both of the triangles, and then you add the two triangles together, and lo and behold, you get, I'll put A with a little R underneath of it for area of a rhombus. And the area of a rhombus is exactly the same as the area of a, what was the last thing we just did?
Kite.
A kite, right. So the area of a rhombus is the same as the area of a kite. Do you remember what the area of the kite is? That's it. 1/2 the product of the diagonals. Okay? So if I multiply the two diagonals together and then take half of it, that's the area of this rhombus. It's the same as a kite. All right? It's the same area as a kite, which is nice to know. It's one less new thing we have to remember, right? So you already remember this from the kite. It's the same thing with the rhombus. Everybody good with that? All right. Let's do an example, and then we'll do one more example, and then we'll be finished section 7.2. So I'll tell you what. Let's just grab this. Put it right there. Oops. Come on. Grab it. Grab it. Why can't I grab it? I have this other program I use. It's InDesign, which is a desktop publishing program. And when I draw shapes like this, I can grab it every single time. I don't know why on this particular program. It's the same manufacturer, same place that makes it, Adobe. But for some reason, I can never grab those. All right. Let's put some diagonals in here like we did before. Okay. Now they're going to give you some information, and they're going to ask you for something a little bit different than we're used to. So let's just keep this yellow. Let's make this is 5, right? Now, why in the world would they give you this? Because that's not even one of my diagonals. The only thing I know about the area of a rhombus, by the way, this is a rhombus. It tells you. Okay, so they tell you that it's a rhombus. Everybody with me on that? So we don't have to figure it out. They tell us that it's a rhombus. But look what they give you. They give you one of the sides of the rhombus. Does that have anything to do with the area of a rhombus? No, because what's the area of a rhombus? 1/2 times the product of the two diagonals. But they do give you some other stuff. They give you this little bit right here is 4. That means from the intersection to this point right here. Okay? And then they give you this little bit right there is 3. Everybody see that? Okay. And it's perpendicular. By the way, if this is 3, what's this right here going to be? It's going to be 3. Okay, and if they give you this as 4, what's this little bit right here going to be? It's going to be 4. Again, why? We said it earlier. Because the diagonals do what to each other? They bisect each other, right. Remember, this is a parallelogram, okay? This is a parallelogram, and it's a rhombus, right? It's just a specific parallelogram. It's just a parallelogram with 4 equal sides, basically. So what we have to do is this. They're not asking you to find the area of this thing. I guess they could. They're asking you to find the height. Find the height. Actually, they are asking. You do have to find the area, sorry. So you have to find the height. Where in the world is the height? Let's put that in a different color. We talked about this. How do you find the height of it? Is it one of the sides? Is that the height? It's perpendicular, right? It goes from one point, right, on here, perpendicular to the other side. So we could go here, like straight down here, perpendicular to here, okay? But this is what they do. This is probably what I would do as well. They just take this side right here and extend it to about there, and they take this, they make that go right there. So this right here is the height. Remember, it's got to be perpendicular. Now, I could have drawn it outside it. I could have put a point here and just dropped it perpendicular to here if I wanted to. It just looks a little nicer if you just put it out here and it's not in the middle of all this stuff. All right, you with me on that? I could have taken it here and put it here. I could have started from here and popped it up like this if I wanted to. Wouldn't all those distances still be the height? Yeah, as long as it goes from one side perpendicular to the other, then the heights would all be the same. So the question is how to find the height. I don't even have height in my rhombus equation or formula, do I? I just have the 2 diagonals. But remember what this is. This is it's a rhombus, but if it's a rhombus, it's also a, no, it's not a kite. It's definitely not a kite. What is it? It's a parallelogram, okay? Do I know the formula for a parallelogram, the area formula for a parallelogram? Look in your notes. Flip back a couple pages. It's base times the height. Exactly. So watch. The area of I'll just put P for parallelogram, is equal to the base times the height. Okay? Do I know the base of this parallelogram? What is it? It's 5, exactly. Do I know the height? No, I don't. So I got one thing I know, which is the base. I don't know the height. Do I know the area? Do I know it straight up? Do I know it like, did they give me the area? Say it, right, Braden. You got to find the area. That's right. So we can find the area now, can't we? Everybody with me on that? Put this in a different color. So let's find the area of the rhombus. Why do we want to find the area of the rhombus? Because it's the same thing as the area of the parallelogram. Because this rhombus is a parallelogram. Agreed? All right. So we're going to find the area of this thing. And then with that, we're going to find the height. Because I could just put the area right there. I know the base. I can find the height. Everybody got it? Okay. So let's find the area of this thing right here. Well, it's a rhombus. We just talked about what the area of a rhombus is. It's what? It's 1/2 times the 2 diagonals. Okay, the product of the 2 diagonals. You know what product means? Multiply, right. All right, so what are the 2 diagonals? Is it 3 and 4?
8 and 6.
It's 8 and 6, right, because the diagonal is the whole thing from here to here. They only gave you part of it, which is half of it. How do we know it's half of it? Because they're bisected. All right, see how it all comes together? All right, all those little things that we learned in the past, they all come together for this one particular problem. All right, so what's the whole thing? 8 and 6. You could do this however you want. You could go half of 8, which is 4, times 6, which is 24. Or you could go 8 times 6, which is 48, and then a half of that is 24. Or you could go half of 6, which is 3 times 8 is 24. Any way you do it, you get what? 24. Do they tell you it's in meters? Okay, yep, it's in meters. So the area would be what? Meters squared, okay? But that's not what they ask for, is it? They ask for the height. But now that we know the area and we know the base, now we should be able to find the height. Would you agree? Right? Let's do this. Instead of plugging the numbers in right now, let's get height by itself right now. Okay, we talked about this a day or two ago, didn't we? It said when you take physics, you're going to want to they call it this. They say isolate the variable. Get the variable by itself, okay? So let's get the variable by itself, and then we can plug all the numbers in. Make sense? So let's do it. So how do we get h by itself? What do I do with that b? Divide by b, and then I divide this by b. So the height is what? The area divided by the base. All right, so the area, we just found it. What is the area? 24, and it's meters squared. Okay, what is the base? It's 5 right there, and it's 5 meters. Okay, and now you just do the math, and that comes out to 4.8, and that's meters. Okay, and the height should be in meters. Agreed? It shouldn't be meters squared. The height, remember, the height is just a distance. Okay, it's not squared. The area is squared. And notice, the meters squared over the meters. See how that meter right there cancels out with one of those meters there? And we're just left with meters. And then that would be our answer. Anthony.
So if like we had to like do that and like divide, do we have to like put it in the like actual formula, or can we just like after we find our area, we just do
You could just plug it in. I'm just showing you. I'm just trying to get you used to getting a variable by itself with just letters, okay, and then plugging it in. But yeah, absolutely. You could put, you could just use this right here and plug the numbers into that. So you could go 24 equals 5, right, which is the base, times the height. You could do that and then divide both sides by 5. That's fine. Okay, but what I'm trying to do is I'm thinking of the future. I'm thinking later on you're going to have big, long formulas, and you're going to have to solve for one of the letters. You might have 3 or 4 different variables, okay? And you're going to have to solve for one of the variables. I think, personally, and a lot of teachers think, it's probably easier to get that variable by itself first and then go ahead and plug everything in. But sure, you could plug everything in right now. But just imagine if you had 4 different variables, okay? Maybe 5, and you're trying to find that 5th variable. You plug everything in, you're going to have a whole bunch of numbers around. I really think it's easier just doing the algebra with the letters and then plugging it in. But yeah, either way you do it, it's fine right now. Okay, yes. All right, one more example and we'll be done. We've been doing this a little bit here lately. Yeah, let me grab this thing. Right, we've been doing a lot of that coordinate stuff here lately, haven't we? We had a whole section where we just did a bunch of stuff with the coordinates. So they're going to throw those in every once in a while. So I think it's really important to be able to do these. All right, I'll put it off to the side and then I'll do my work over here. So here's what they do. It says find the area of quadrilateral WXYZ. And here are the letters. I'll write them down. So W is 4, 1. X is 1, -3. Y is -2, 1. And Z is 1, 5. And it says find the area. Find the area of this quadrilateral. Okay? What do you think our first step is? Talk to me.
Draw it.
Yeah, draw it out. That's right. Plot the points. Wouldn't you agree?
Yeah.
What's easier to see, yellow or blue? Or pink? Blue? We'll use blue. All right, 4, 1. So let's do that. 1, 2, 3, 4, 1. Right there. Everybody should be good at this stuff now, right? X is 1, -3. So 1, -3. 1, 2, 3. And -2, 1. -2, 1. And then 1, 5. 1, 1, 2, 3, 4, 5. Right there. All right, there's our quadrilateral. Well, let's draw the thing out. There to there. There to there. Oops. Should have started here. And then there. All right, so we're trying to find the area of this thing. Well, we got to figure out what kind of figure it is. Okay, what kind of polygon is this thing? Well, it's a quadrilateral. Okay, but that's pretty general. We got to be a little more specific. What do you think it possibly is? Looks like a rhombus, doesn't it? How do we know for sure if it's a rhombus or not?
Oh, we can draw that.
We could draw the diagonals. That would help. Okay, why would that help?
Because you would find out if it's
Okay, if they bisect each other. Okay, actually, you don't even have to say they bisect each other because that's true for any parallelogram. Okay, but if they're perpendicular, okay, if the diagonals are perpendicular, then it's specifically a rhombus. Would you agree? you could find that they bisect each other, but that just means it's a parallelogram. It doesn't necessarily mean it's a rhombus, okay? So we want to get as specific as we possibly can. And let's do the diagonals, right? They made this kind of easy because the diagonals are nice and horizontal and vertical, okay? So they made this kind of easy for us. So what I'm going to do is I'm going to see if these diagonals are perpendicular. How do I? Yeah, they look perpendicular, okay, and especially if we use the graph, right? One's horizontal, one's vertical, so they sure look perpendicular. But how do I know for sure if they're perpendicular?
Find the slope.
Find the slopes. Very good. Okay, and oops, what would be? Let me grab. There we go. Just want to turn that into blue. So let's put some stuff in there. This is 1, 5, right?
Yeah.
This is what, 4, or what is it? 4, 1. 4, 1. This is what, 1, -3. And this one is -2, 1. That might help us just a little bit, okay? Let's find the slope of the vertical one, the one that's going up. Well, I don't know if it's vertical just yet, but yeah, I do actually, because look, I went over 1 and I went up 5. I went over 1 and I went down -3. So I went over, right? I did the run right here, is exactly the same. Wouldn't you agree? So what is the slope? It's a 0 slope. Very good. Okay, so we take the y's and we subtract them.
Well, actually, it says undefined.
I'm sorry. You're absolutely right. The other one is 0 slope. This is undefined. Now, why? Because how do we find the slope? We subtract the y's, right? So if I subtract the y's, what do I get?
0.
No, the y's. 5 minus -3.
2.
It's 8, positive
Oh, yeah.
8, right? So look, I'm at 5 here, and then I go 3 down here, so that's 8. You could just count if you wanted to, but it's 5 minus -3. Agree? What about the run? Well, the run is 1 minus 1, which is 0. So what is that number? It's undefined, isn't it? It's undefined, which means if it's an undefined slope, what kind of a line is it? It's a vertical line. Agreed? So I know it's vertical. It sure looked like it was vertical when I drew it, and sure enough, by the math, it's definitely vertical. We got it? Let's do the same thing with with this one that looks horizontal. Let's just make sure it is. Well, I kind of know it is because look, I went up 1 and I went up 1. So I went up the same distance. So it's got to be horizontal. Would you agree? But let's do it math-wise. So again, we find the slope. We subtract the y's from each other, which is 1 minus 1, which is 0. And does it really even matter what my run is right here? It doesn't. But -2 minus 4. Or actually, it doesn't matter which. It's 6. Okay, that's the length of it. And what is that? It's 0. Is 0 and undefined the same thing?
No.
No. So if it's a 0 slope, it's a what? It's a horizontal line. So if it's a horizontal line, what's true about a horizontal and vertical lines? They're what to each other?
Equal, bisecting.
Perpendicular?
They're perpendicular to each other. Okay? Which means the diagonals now are perpendicular, which means, and the whole reason we went through this is just to be able to know for sure that this blue-looking quadrilateral is a what?
Oh.
It's a rhombus now. So now we can say, without any shadow of a doubt, that this is a rhombus. Why did we care that it was a rhombus? What are we trying to do?
Find the formula.
We're trying to find the formula of the area of a what? Of a rhombus, okay? If it was just any old parallelogram, then that's a different formula than the area of a rhombus. Do you agree? Right? Well, they give you different stuff because the parallelogram would be the base and the height, but the rhombus would just be the 2 diagonals, okay? So all you got to do is find the 2 diagonals. Everybody with me on that? Now, again, this one they make fairly easy for you because you could just count if you wanted to, and we've kind of done it already, haven't we? So let's put the area. Area is 1/2. Oops, there we go. It wouldn't be a math class unless I did that. Remember, it's diagonal 1 times diagonal 2. So let's plug it in. 1/2. Let's find the 2 diagonals. Well, this one going up and down, we kind of did it already up here. 5, -3. What's the length of that?
8.
It's 8. Okay. What about across right here from -2 to 4? How far is it from -2 to 4? That would be 6, right? It makes it really easy when they're straight across and straight up and down. Would you agree? Yeah. Now, if it was slanted, you're going to have to go through the whole distance formula thing. All right. But, and there we go. It's 24 again, just like we did. Now, yeah, they don't give you any units on this. So if they don't give you any units, what should we write? Units, right. Squared. Oops, there we go again. Second time today. Units, what? Squared. Okay. And that would be the area of that, which we know now is a rhombus. Okay. Initially, we only knew it was a quadrilateral because it had 4 sides. But we did some, right? We know some stuff. We took, and we know now it's a rhombus. And that would be the area of it. Well, that's it. So, we will go over that worksheet. I'm going to give you the answers to that worksheet just so you know if you did them right or not. It was pretty basic, that worksheet, I think. And then, did I officially assign anything yesterday? 1 to 14? Yeah. Okay, so, where'd my pen go?
It's gone.
Where'd it go? Oh, well, I'm glad it quit now instead of in the middle. It's been doing that. I think I got a bad connection or something, but the little light's on.
Isn't the thing saying? Are we turning this one in today?
The 1 to 14, I'll let you turn in tomorrow. Okay. Well, I can't write on this thing. My pen died. So we'll stop recording. Well, actually, let me just say what we're going to do. So, yeah, I gave you 1 to 14 to do yesterday, okay? So that should be done. But we got this is chapel day, isn't it? So I got like 12 minutes. So maybe we'll go over some questions on the board. I won't do it on here, but I'll do it on the board of 1 to 14. So tonight, what you're doing is 17 to 25. So we're still up to date on our lesson plan thing, all right? Yeah, just do it. I'll give you 10 points. Okay, remind me tomorrow, though, when I collect it that it's 10 points, okay? But yeah, we'll do that. So it's going to be basically 1 to 14, 17 to 25, and it'll be one assignment. I'll give you 10 points on it since it's quite a bit of stuff. Yes, sir.